crowbar of length 120 centimeter has its fulcrum situated at a distance of 20 centimeter from the load. Calculate the mechanical advantage of the crowbar. So we have the total length of the crowbar. If you observe, crowbar is something like this, and in case of a crowbar we place the fulcrum like this. So this is the fulcrum. Alright, now total length of the crowbar has been set as 120 centimeter. So here we place the load, and here, so load is acting downward. Here we have the effort which is going to act in the downward direction. Now it says that its fulcrum is situated at a distance of 20 centimeter from load. So load is here, fulcrum is here. So this distance will be your 20 centimeter. From here to here, this distance is 20 centimeter, and thereby this distance will be your 100 centimeter, which means that load arm will be equal to 20 centimeter, effort arm will be equal to 100 centimeter. As a result, mechanical advantage we have to calculate, which will be equal to effort arm upon load arm, that is 100 upon 20, it comes out to be 5. Okay, so this is the crowbar, and this is how we are using it. Simple one. You just have to identify which type of lever it is, and then you can place the fulcrum. Where will be the load, where will be the effort, and accordingly you can find out the load arm and the effort arm. Okay, I move to the next question. Question number 2. A pair of scissors has its blades 15 centimeter long, while its handle are 7.5 centimeter long. So if we try to make the blade pair of scissors, okay, something like this. Blades are longer, so blade is 15 centimeters, so this point will be your fulcrum. This will be your load side, this will be your effort side. So length of the load arm 15 centimeter, effort arm 7.5 centimeter. So what we get, load arm is equal to 15 centimeter, effort arm is equal to 7.5 centimeter. So again what we have to do, we have to find out the mechanical advantage. Mechanical advantage, effort arm by load arm is equal to 7.5 upon 15. It comes out to be 0.5. Now keep in mind, two things I am always writing. One is your formula, and the other is the substitution of the formula. These two steps should be shown. Okay, if you write down the above two steps also, it is well and good. Otherwise these have to be shown. So I hope this is clear, so I'm just moving ahead. After 3-4 questions, I'll come to the chat part to clear your doubts. Question number 3. A force of 5 kg is required to cut a metal sheet. A shear used for cutting the metal sheet has its blade 5 cm long while handle 10 cm long. Now shear, actually we say is just a sort of a scissor, but the difference is that in case of a shear, the blade part is small and the handle part is long. So this is your load, this is your effort. And as a result, it says that load arm, that is the blade, length of the blade, that is your 5 centimeter. Effort arm, that is length of the handle, that is 10 centimeter. Okay, and it is used, a force of 5 kgf is required to cut the metal sheet, and we have to find out what is the effort needed. So load, that is 5 kgf. So first of all, mechanical advantage we have to calculate, that is EA upon LA is equal to 10 upon 5 equal to 2. So you'll find that all these force multiplier are having a mechanical advantage greater than. Now we have to find out the effort. So once we calculate the mechanical advantage, we can also write down mechanical advantage. This is the first part, or not first part, only one part we have. But this is the first part which we will be calculating to find out. Mechanical advantage in terms of load and effort is your load by effort. As a result, we can find out effort as load by mechanical advantage. This load is given as 5 kgf, mechanical advantage is 2, and as a result this comes out to be 2.5 kgf. Okay, so I hope these 3 questions are clear to all of you. Then we have question number 4. Question number 4 says, the figure below shows a lever in use. Okay, so we have to mention the class of the lever, we have to find out the mechanical advantage and the value of E, that is effort. So this is your first class lever. One side is load, fulcrum and effort. Load is equal to 15 kgf. Now this is A, F, B. Now AB is given as 1 meter. AB is equal to 1 meter. Okay. AF is given as 0.4 meter. Now if you try to see, AF basically represents your load arm. Okay. So mechanical advantage we have to find out. So we have to find out the FB. .0 minus 0.4 equal to 0.6. Okay, this much meter, and this will basically represent your effort arm. So mechanical advantage, if we have to find out, EA upon LA, EA is 0.6, LA is 0.4, and it comes out to be 1.5. Keep in mind, mechanical advantage, you are not going to write down any unit because it doesn't have any unit. So this is your B part. First A part I hope all of you know, that is why I have not told to which class. This is class 1 lever. And then C part we have to find out the value of E. So again E we can use it using MA is equal to L upon E, or E will be equal to L upon MA. This is given as 15. MA is 1.5, so it comes out to be 10 kgf. Okay. I hope up till here it is clear to all of you. In case if you have a problem, you can ask in chat. I am going to the chat portion. Right, Manu? I hope you don't have any question related to first 4 numbers. Let this be a crowbar whose length is 1.5 meter. To raise a load of 75 kgf, so here we are placing a load L equal to 75 kgf. Here we will have a fulcrum below the bar at a distance of 1 meter from his hand. Now when it says at a distance of 1 meter from his hand is basically been used to apply the effort. So the fulcrum is placed at a distance of 1 meter. So I hope it is clear to all of you that the fulcrum, that is from this point to this point, is your 1 meter. So now what we have load equal to 75 kg. Okay. So first part we have to draw the diagram of the arrangement showing the fulcrum load effort with their direction. So direction I had already shown. Then state the kind of lever. So the kind of lever, because the fulcrum is lying in between, so this will be your class 1 lever. Now calculate the load arm. So C part, first one, load arm. So load arm will be your from here till here. Okay. So that means from total 1.5 minus 1.0, this will give you the load arm, that is 0.5 meter. Then we have the effort arm, which is already given as 1.0 meter. Then we have to find out the mechanical advantage. So we'll write down the formula. EA upon LA, this is equal to 1.0 upon 0.5. This comes out to be 2. And then the effort needed. So fourth part, effort needed. So we can use the formula MA is equal to L by E. So E will be equal to L, sorry, E will be equal to L upon MA. L is given as 75. 2, it comes out to be 37.5 kgf. Okay. So I hope this is clear to all of you. Now we move to the next one, and I move to the question number 7. A 4-meter long rod of negligible weight is supported at a point 125 centimeter from one end. So we have a rod which is, let AB be the rod whose length is 4 meter. I am writing down in centimeter because the other values are given in centimeter. Okay. Now, this rod is supported at a point 125 centimeter from one end. That is from, say, from A, it is at supported means the fulcrum will be at 125 centimeter, at a distance of 125 centimeter from one point. So if I consider that from here, so let it be 100, 200, 300, 400. So 125, let it be at this point. So we have a fulcrum at a distance of 125 centimeter. Clear? A load of 18 kg is suspended at a point 60 centimeter from the support on the shorter arm. So from here, at a distance of 60 centimeter, a load of 18 kg F. So this distance is considered to be as 60 centimeter. Okay. It is not exact location, it is saying that as a centimeter. Okay. It is just saying that it is this much point from this end or this much point from the support, which means that is this much distance. Okay. Support on the shorter arm. Now, A part it is asking if the weight W is placed at a distance of 250 centimeter from the support. So at a distance of 250, round about here, this is W, and this distance happens to be 250. Okay, so we have to find out W. Very simple case. If you observe, load is considered to be as 18 kgf. Okay, so we can say L is 18 kgf. Effort is equal to W, and then your load R is equal to 60 centimeter, effort arm equal to 250 centimeter. So according to law of lever, load into load arm is equal to effort into effort arm, which means that 18 into 60 is equal to W into 250, or is equal to 18 into 60 upon 250. On simplification, we get the value as 4.32 kgf. Alright, comes out to be 4.32 kgf. Similarly, we come to the B part. Now it says that if a weight of 5 kg is kept to balance the rod, find its position. Now definitely, if I have to balance this 18 kgf, 5 kgf has to be kept on the other side of fulcrum. So let it be placed at certain distance. This is x. This is 5 kgf. Okay.
ये रखा है
And let it be placed at a certain
अभी तो इसमें
distance
जो है आने आएंगे ना अभी जो क्लास
x
खत्म हो
from
दे
the
देंगे
fulcrum. So now, if we
यहाँ
apply
रखा है अभी
the
क्लास
same
खत्म हो
rule,
जाए
so
अब
here
अभी
we
अभी
have,
क्लास खत्म हो जाएगी दे देंगे
I'm not writing down all the
दिखाने को
things.
क्या है रखा ये
L
रखा है
into
नहीं
LA
अभी अभी दिखा देंगे
is
नहीं
equal
नहीं अभी
to,
अभी जो है क्लास हो जाए देते
now
हैं
मुझे तो
E
पकड़ा तो दो
into
लीजिए
EA.
गेम देख ही नहीं रहे पहले देख रहे तब जो है काम कर रहे दीजिए
कब देख रहे हो ये कहाँ देख रहे हो
ये पहले देख रहे थे ना अब नहीं देख रहे दीजिए रखा हुआ तब से बंद हो गया देखिए बैटरी इतनी कम बची है कहाँ से देखेंगे ख़त्म हो जाएगा हाँ ठीक है
Okay. Now here, this part will remain as 18. This part will remain as
नहीं वो सुबह
60.
से देखे तब देखे
Okay. This part, effort will now will be, we are not going to consider W and now at moment. Okay. Now we will consider the effort as 5 and therefore effort now becomes X. Which means that if you try to simplify this, I'll just rub some portion of it. So if we simplify this, we get x is equal to 18 into 60 upon 5, which comes out to be 216 centimeter. Or in terms of meter, it will be, because answer is given in meter, you can also leave it in centimeter. 2.16 meter or 216 centimeters from the fulcrum, that is from the support. So this is how you are going to do. And the last part, to which class it is lying. So you see fulcrum is in the center, therefore this is class 1 lever. Okay. So I hope this question is clear to all of you. If you have any problem, you can ask. In question number 5, putting the sharp edge. Sharp edge here means the fulcrum. Or generally in a crowbar, what we do, we keep a certain block so that we are able to apply the effort and the crowbar can rise from the other side. C part. C part. What happened? Divyanshi, what happened to C part? C part is class 1. Okay, Archa, you were giving the answer. Any other confusion? No. So we move to the next question. Some of you are leaving also, na? keeping the 18 kg of weight on one side. So definitely to balance it, we have to keep it on the other side. So that is how we are trying to make out. Question number 6. If you see the scissor, the middle part where the two blades are being joined, and mostly that has been riveted. Okay, riveted means instead of using a nut and a screw, that has been a rivet sort of uh, device which has been used. Rivet is basically in case of your bags another where it has been sealed. Now 5 kg weight where to keep. Okay, again 18 kgf is going to be there, so we are going to place 5 kgf because W has now no meaning in the second part. Okay, so definitely it has to be placed on the other side. Why don't you go for the school mitra beta? Mira, it's better to use a school mitra because directly using a Zoom will create a problem, might create a problem. Okay. All right. Okay, but most of the time it opens to